Hello, this is Mr. Professor. In this video, I will talk about what spectral graph theory is. Many of you know that graph theory has its origin in Euler's solution to the Koenigsberg 7 bridges problem by considering the set of vertices and the set of edges. Spectral graph theory emerged in 1950s and 1960s. Spectral graph theory is a branch of mathematics that combines linear algebra and graph theory to analyze the eigenvalues and eigenvectors of matrices derived from graphs, like adjacency matrix, Laplacian matrix, etc., to understand the structure of graphs. For example, let A of G be the adjacency matrix of a graph G with the vertices 1 through n. Then the ij entry of A of G is the number of edges between the vertices I and j. So for a simple graph G, the ij entry is just 0 or 1, depending on the existence of an edge between the vertices I and j. Since A of G is real and symmetric, all its eigenvalues are real. If lambda is the largest eigenvalue of the adjacency matrix of G corresponding to the eigenvector x, so like A of G, x is equal to lambda x. By considering i's entry of A of Gx, so lambda x of I, so i's entry in here, and i's entry of here. So this is equal to A of G, ij, xj, and j is adjacent to and I in here. Well, if you consider just a simple graph, then A of G, ij entry is just 1. If j is adjacent to I, okay, then you can just remove this part. But if you consider multi-graphs, then you have to consider this one because it may be 2 or even bigger than 2. So if x of I is the maximum positive entry of x, then lambda x of I is equal to the summation A of G, ij, xj, j is adjacent to I in here. Because x of I is the maximum positive entry, so this is less than equal to x of I in here because x of I is greater than equal to x of j for any j in here. And the summation of A of G, ij is less than equal to maximum degree and here. So from this inequality, you can conclude by dividing x of I, by dividing by x of I, you can have a lambda is at most the maximum degree. So we have the relation between the maximum degree and the largest eigenvalue. Also, by the Rayleigh equation, we know that the largest eigenvalue is equal to this. So if I replace x with 1, lambda is greater than equal to, because this is a max in here. And here, this is a transpose. I missed it here, sorry. Transpose in here. So 1 transpose A over G and 1. And 1 transpose and 1 in here. So the top equals the actually degree sum, or you can put just a 2 times number of edges here. And the bottom part is number of vertices in here. So you can see the largest eigenvalue is greater than equal to average degree. And we know the average degree is also greater than equal to minimum degree. So we have the relation between the average degree and the largest eigenvalue, or the minimum degree and the largest eigenvalue. We may get a lot of information between a certain eigenvalue and a certain graph parameter. You may try to find a relation between them. Then you can be a spectral graph theorist. Thank you for watching.